Well, hey everybody, how are we doing today? We are finally moving away from rules and regulations and stuff and actually starting to put some of this into use. So we are going back now to chapter 2. We're actually doing 2 sections today, 2.1 and 2.2, which is solving one-step equations. Should be mostly a review, hopefully, and solving two-step equations. Where we start to introduce something new in the one-step equation is we're introducing a new property called the zero product property, and you'll see what happens when we get to that. Just in case you did not know, solving equations is kind of like, I always call it kind of like a scale. Like the scales of justice, everything is supposed to always be balanced and equal. Equations are just like this. Both sides, on both sides of that equal sign, must always stay equal. And no matter what we do to one side, we always have to do that to the other side. So we have to think about that and keep that in our heads as we start to work with these particular equations. Equations are really no much different than an expression like we've been dealing with set equal to something. So now it says all this stuff on one side equals this on the other side. And again, we have to sometimes algebraically manipulate it using properties, and we have new properties. This algebraic manipulation that we'll be doing to them isn't like we're pulling it out of the sky. It is an actual property, and it has a process to it. What can we do to equations? Well, we can add or subtract things from both sides. We can multiply or divide things from both sides, and we have properties that allow us to do that. It's the addition/subtraction property of equality. I sometimes represent it, maybe if you don't want to write that whole thing out, like, because we should be justifying each step that we do when we do a problem. I just use this little quick notation, plus minus equal, addition, subtraction, equality. Or multiplication, the multiplication sign, the old-fashioned division sign, equal. It's shorthand so that we can make sure we're documenting to ourselves, I know what I'm doing, I've documented it. Okay, but we need to make sure that we know how to use these particular properties. They must be known. Now, to start off with, we're going to look at these first two examples. This should be hopefully a very simple example here. You have what? X minus 4 equals -9. It's a little different, a little harder than your normal one-step equation. Because, we have these horrible little things here, subtraction signs and minus signs, which we seem to have totally forgot how to do. This has been since the beginning of the year, guys. Our biggest bane of existence is that we are not learning, and it's like we almost refuse to learn how to add and subtract negative numbers. We have to practice this. We have to put it in our minds. We have to keep doing it because, like I said, it's not going away. It just gets more complex as we keep going. And it really stinks to do a problem like this. And because we have a small sign error, we have the entire thing wrong. Okay, so let's be very careful this lesson and try to remember these rules so that we're adding and subtracting negative numbers properly. So our goal when we do this is we want this X. We want that X to be all by itself on one side. Okay, it must be all by itself on one side. And in order to do that, well, we have to use these properties that we have. We're either have to add or subtract something on both sides to help us get X by itself, or we have to multiply or divide. Our goal is to always make the problem as simple as we can. So first thing I like to do, I like to make my scale. Remember, this is a scale. What we do on one side of this scale, we have to do on this side of the scale to keep the equation balanced. Now, I look at this. This is the simplest form that we have, right? We have an X. So X has to stay here. Well, what else do we have next to it? We have this -4. All we need to do is the reciprocal property of whatever is being done. We're taking away 4. So if we take away 4, the opposite of taking something away is adding something. So if we take away 4, we have to add 4 to this. That'll make the 4 go away. But we can't just say, okay, so negative 4 and a positive 4 only leaves me with x, because these will cancel out. And say, all right, that equals negative 9. No, we can't do that. Our rule up here says the addition/subtraction property of equality states that if I add something to one side, I have to add it to the other side as well. So this step here is the addition/subtraction of equality. Notice I justified why I did this. Now we can do this math. Negative 9 plus 4. If you're still having a hard time with this, if you see negative numbers, consider it like money. I owe somebody $9. I pay them back 4. So how much do I owe them? Because the negative number is bigger than the positive, I still owe them 5. So we think that x equals negative 5. Now we have to check our work. So this is when we're going to use our substitution property. We're going to take this equation. We're going to remove the x and insert a negative 5. We're going to evaluate it. I have a negative 5, and I take away 4. Well, what does that equal? Negative 9. So I just proved and checked that this is correct. I have checked my work. So yes, x does equal negative 5. I want everybody on their papers to make sure you are stating your justification. You must show this, and you must show this. I do not want you just inputting answers. I want you to check your work, and I want you to justify each step while you're doing it. Let's look at the next one. Ooh, this one, look, we have more going on here. So again, let's just start off with our little scale. All right, x is over here. I'm circling this because that's where my x is, the term that has my x. I can't do anything with this until everything else is gone from this side here. So I have a minus 4. The opposite of taking away 4 would be adding 4. This is the addition/subtraction property of equality. So 8, 9, 10, 11, 12. These cancel, and I'm left with 3x. It comes down. Now that everything else here is gone, now I can deal with this 3, and this is where like a 2-step kind of deal comes in. Okay, so I've done one step. Now I have to do a second step. How do I get this x by itself? While I look at it, what is this? What's happening with this 3 and this x? Right, they're being multiplied together. So in order to undo that, again, I'm going to make my little scales. Because what I do to one side, I have to do to the other. The opposite of multiplication, or the reciprocal property of it, is division. So if I'm multiplying by 3, I can divide by 3. And if I divide by 3 on one side, I have to divide by 3 on the other. So these will cancel, and I'm left with an x. That was a really ugly x. I'm left with an x. And 12 divided by 3. If I reduce that, well, 3 goes into 3 once, and 3 goes into 12 4 times. So that's like 4 over 1, which is just a 4. So I think my answer is 4. I have to test that. So you come over here and you have to test it. So you'll have a 3 times 4 minus 4. Well, this is what? 12 minus 4, which is 8. So yes, that checks and x equals 4 is my solution. You can check your work. There's no reason to miss any problem on this section because you have the ability to take the answer that you think you have, plug it in, and make sure it works. Well, how can we take something that we should have learned in the past, like, the one-step equations, and we have to we have to step it up a notch for algebra? Well, we have this rule here called the zero product property. It basically states the product of two things that equals 0. Okay? If there's a product of two things that equals 0, then each piece is equal to 0. Notice, what have we been doing in the last section? We were multiplying binomials together. So we had two binomials that multiplied together. Well, what happens if both of those, when we multiply them together, our product is 0? Everything inside the boxes cancel out, and everything goes away. Well, then the product of those are 0, so we can then say each individual binomial is also equal to 0. So we can rewrite it. So when you see something like this, two binomials sitting side by side in parentheses, and they say it equals 0, we rewrite each piece and set it equal to 0 and solve. We're going to get two answers for this. So this one problem gives you two solutions. Well, look, this is a one-step equation. You have your little scales. Oh, and these little scales here are what? You have to add 1. So if you add 1 to one side, you have to add 1 to the other. So x equals, these cancel, x equals 1. 0 plus 1 is 1. That was the addition, subtraction property of equality. And look, take a look at this real quick. 1. So 1 minus 1 equals 0. So it's true. Look at the next one. You put your little scales here. All right, so we have a positive 2. The opposite of that is subtracting 2. If we do it to one side, we have to do it to the other side. These cancel. X equals, well, 0 minus 2 is a negative 2. And let's test it. Negative 2 minus 2 equals 0. That is true, so it checks out. Now, when we get two answers like this, there's two ways to represent them. We have to be careful. We have to read directions. Our directions may just have like x equals, so we plug in this. Or it may say separate your answers using a comma. So when you do that, these weird little brackets pop up. These are brackets, and it's a set, and there's a comma in the middle. Notice, this is not a set of parentheses with a comma. A set of parentheses with a comma is an ordered pair, like you're going to graph on a Cartesian plane. You move one spot to the right, 2 spots up, 1, 2. These are not ordered pairs. These little brackets mean it's a set, means it's a set of solutions. It's a set of answers. It's a set of something that has some sort of relation to it. Okay, this is a set of solution, or a solution set, so it's 1. It already has the comma, minus 2. Your solution set is 1, negative 2. What about this one? Why don't you guys try to do this? Remember, set it up. It's two separate problems. The zero product property says that the product of two things equals 0. All right, so if the product of two things equals 0, set each piece equal to 0 and solve. You guys go for it. You try it, pause it, and see what you get. All right, hopefully, if you paused it and you tried, you should look at something like this, right? 2x plus 4 equals 0. I'll just draw a line to separate them, and then you have an x minus 5 equals 0. Well, if we're going to solve this, this is the old-fashioned easy one. Add 5 to both sides, because if you have a minus 5, you're trying to get rid of it, you have to add 5. So the addition slash Subtraction property of equality states if I add 5 to one side, I have to have 5 to the other. These will cancel, and I bring down my x. 0 plus 5 is 5. And I can see that 5 minus 5 is 0, so I know this works. So one solution is 5. Now I have to find my other solution. And I can tell right away, this is a bigger problem. This is a two-stepper. So the opposite of 4, positive 4 is a negative 4. So if I have a positive 4, I have to subtract 4 to make it go away. That leaves me with 2x equals negative 4. And then this 2 is being multiplied. So the opposite of multiplication is division. Now these can cancel, like 2 divided by 2. Anything divided by itself cancels out. Well, if I divide one side by 2, I have to divide the other side by 2. Here's where we have to be careful. Why? Why do you think we need to be careful? Again, right here, it's that pesky negative sign. We are doing a negative sign, and you have to be careful. A negative divided by a positive, your answer is going to be negative. All right, so 4 divided by 2 is 2. And we can test this. Okay, let's test and make sure, because we have this thing here, right? So 2 times a negative 2 would give me a negative 4, right? A negative 4. And negative 4 plus 4 equals 0. So yeah, this works. Like we did here, 5 minus 5 is 0. Yes, that works. So our answers are, separate your answers using a comma, would be 5, comma, negative 2. And you're good to go. Let's start to look at some straight examples of these equations here with 2 steps. Again, we need to make sure that we are setting up our problem. I like to draw the scale. All right, what I do to one side, I must do to the other. I see I have a 10w plus 2. This, I like to circle. I know that these are stuck together. I can't do anything with these whatsoever until everything, all this stuff is gone. So what do I have here? I have a plus 2. So that means I have to take away 2. The constant is the first piece that has to leave. If I do it to one side, I have to do it to the other side. This is the addition subtraction property of equality. All right, so now these will cancel, and I get a negative 8. Because if you owe somebody 6 and you borrow $2 more, you owe them 8. We have to get these negative signs right, guys. Carry down everything else. All right, now that the only thing that's left here is this term with the W, we have to say, well, what's this 10 being done to this W, right? What's being done to that W? So we need to say, hey, that's being multiplied. So the opposite of multiplication is division. And if we divide one piece by 10, we have to divide both pieces by 10. It's the multiplication division property of equality. All right, so these cancel, and it leaves me with a W on this side. Now we have to stop and think. Okay, we have to be careful, very, very, very careful here. We have a negative 8 divided by 10. We have to reduce this fraction. Well, we have a negative divided by a positive, so our answer will be negative. 8. Does 8 go into 10 evenly? No. So let's think of another multiple of 8. Well, I know 2 times 4 gives me 8. Does 4 go into 10 evenly? No. Does 2? Yes. So 2 goes into 8 4 times, and 2 goes into 10 5 times. Now, you might be saying, if you look at that, there's no way most of you cannot look at this problem and tell me, oh, yeah, I know for sure that that is the right answer. No, you need to check your work. You need to set this up, use the law of substitution. If you say that W equals this, then plug it in and you prove to me that's the case. So now we have to go through here and say, all right, I got to look at this and I have to multiply. So 10 times a negative 4 gives me a negative 40. And 1 times 5 is 5. Well, I know now that I see, if I see this here, right, I can say that negative 40 divided by 5 is a negative 8. All right, I know that. And then the plus 2 comes down. So a positive 8, sorry, negative 8 plus a positive 2 gives us a negative 6. Is that what our solution is supposed to be? Yes. So it checks out. Now you've proven to me that this is your final answer. W equals negative 4 over 5. Guys, that is not a straightforward problem. That is not giving us something that answer, negative 4 over 5, is not something that you can just look at and say, oh yeah, I know that's my answer. No big deal. This is one you need to check. Why would you want to miss a problem? Because you don't want to plug it in. How long did that really take us to do? Not long at all. Okay? Be careful. Oh, here's another one. These numbers got way bigger. And look, our variable is on the wrong. Our variable's over here on the other side. Guess what? No big deal. Draw our little scale. Notice this is stuck. We can't do anything with this until all of this is gone. So if we have a minus 24, we have to what? Add 24 to both sides. All right, so these cancel, and I bring down my 12C. Now we have to do the math here. Okay. Well, I can take away 20 out of this would be 40. And then if I take 40 minus 4 gives me a 36. And the bigger number was negative, so it's going to stay negative. Now I have to say, is C by itself? No, it's not. So this was the addition subtraction property of equality. Now I have something being multiplied, so the opposite of multiplication is division. So I'm doing the multiplication division property of equality next. So in order to get this by itself, I have to divide this by 12. If I divide this by 12, I have to divide this by 12. These will cancel, and I get a C. A negative divided by a positive is a negative. And 36, well, 12 goes into 12 once, 12 goes into 36 3 times. So I think that C equals negative 3. Can I make sure it does? Sure. Look, if I put a negative 3 in here, right? I plug negative 3 into here. Negative 3 times 12 is a negative 36. And then I still have a minus 24. So negative 24 plus this is a negative 60. Yes, my work checks out. This is my final answer. And here is our last problem here. Notice what's going on here. This is still an equation, but I have parentheses on this side. I added like a third step. I added an extra property that we've already learned. Can you guys think of what this property is? Ah, you're right. So our very first thing we have to do is distribute. You're right, the distributive property. So 2 times x is a 2x. 2 times 3 is a 6. Notice we didn't do anything that had to do with solving yet. We were expanding. Okay, we're expanding this problem. We're getting rid of the parentheses. So it's not like we were having to do anything to this side. But we still have to say, well, what gave us the right to do this? The distributive property. The distributive property, I'm going to abbreviate that, gave us the right to get to here. Now we have to look and say, I can see that this is stuck together. I cannot move this, so this has to go away first. The opposite of addition is subtraction. All right, so negative 12 plus a negative 6. Two negative numbers together become a bigger negative number. 12 and 6 make 20. So a negative 12 and a negative 6 is negative 20. These will cancel, and I'm left with a 2x. Now we have 2 times x. Well, the opposite of multiplication is division. What we did here, I forgot to justify the addition, subtraction property of equality. Now this is the multiplication, division property of equality. If I divide one side by 2, I have to divide the other side by 2. These will cancel. And I'm left with, we think that x is going to equal what? Well, negative divided by a positive is a negative. And 20 divided by 2 is 10. I do not know. That's my answer yet. I don't know. Neither do you. Do not input your answer. Make sure you take this and plug it in. It has to be plugged in. Yeah, I'm making you do a little work. It's not bad. So negative 10 plus 3 is what? Negative 10 plus 3 is going to be minus 7. And then we have a 2. We distribute. Did that work? Does negative 14 equal negative 12? No. We have done something wrong somewhere in this problem. Something in this problem has gone wrong, and we have to figure out where did we do this problem wrong. This is why I sent this up purposely, guys, so you could see this. Do you know? Maybe we were going through this problem. Do you know where we made our mistake? Let's take a look. Let's look what happened here. Go back to that. So I distributed, 2x and a 6. I minused a 6 from both sides, and I said negative 12 minus 6 is, oh, I see it right here. Look, did I do this? I didn't do this right. I did not subtract negative numbers right. This was my fault. Look at this. Negative 12 and a negative 6 is a negative 18. That should have been negative 18. I made a mistake. So let's fix this and see what happens, okay? This should have been minus 18. Oh, my bad. All right, minus 18. So my 18 divided by 2, well, that changes this answer. Negative divided by a positive is a negative. This gives us what? A 9. Now, if I say that this is supposed to be 9, I can double check this. All right. So 9 plus a positive 3 is going to be a minus 6. And 2 times negative 6 is a negative 12. So now negative 12, there we go. Now we know for sure that x equals negative 9. Guys, this is why I want you to check your work. It's so easy when you have all these multiple steps that you could possibly make one little mistake along the way. And if you do, and you just say, oh, my answer is negative, what would you say, negative 10? My answer is negative 10. You type it in, you're wrong. What did we do? We did a couple steps and realized, hey, this isn't adding up. This isn't correct. Go back, look at your work, and see if you can figure out where it is. And 9 times out of 10, you're going to figure out where it is, and you'll say, oh, good thing I did that, because I might have missed that problem. Your homework is in Delta Math today, guys. Please log on to deltamath.com. It is, of course, titled Homework 2.1-2.2. Have a great one, and I will see you tomorrow.